One of our biggest goals and visions is to make application logic collaborative because frankly right now it's not. It's a silo between design, project management, and developers, and there's very lossy communication between each of those three silos.
Hey, before we get started, we'd like to direct you towards our merch store. You can get some cool devtools-fm merch, or even this TypeScript hoodie. Show how close to the metal you are with this one. If you're a member of our Patreon, you get a 20% discount code. Now let's get on to the episode with David. But remember, the full episode is only available to our Patreon members.
Hello, welcome to the DevTools-fm podcast. This is a podcast about developer tools and the people who make them. I'm Andrew, and this is my co-host, Justin.
Hey everyone, I'm really excited today to welcome David Khourshid, the founder of Stately and the creator of XState. David, thank you so much for joining. I've wanted to talk about XState on the podcast for a while, so this is going to be a really fun episode. Before we dig into that though, would you like to tell our listeners a little more about yourself?
Yeah, sure. And thank you so much for having me. I'm really excited to be on here. So my name is David. I was most recently working at Microsoft. I've been a developer for about 12 or so years. I've lost track at this point. And I was also, I studied piano at university. So that's the last part of my David K Piano username that you'll see pretty much everywhere online. So that's probably my main hobby. But yeah, I live in Florida and now I'm working full time at Stately.
That's awesome. That's awesome. So maybe let's dig right in. So you created this library called XState. People have probably heard about it, and it's around building, or it's a library for building finite state machines and state charts. Could you explain those terms a little bit for our listeners who might not be familiar with them?
Sure, yeah, and they could sound like really intimidating terms, but it's actually a lot easier, than you might think. So in virtually every application, there's like a lot of things that could happen, such as you could click a button, or you could submit a form, or get a response from some API call. And so these things are called events. Events are things that happen in time, but these events don't always have the same behavior. For example, when you submit a form and the form's invalid, or it's already being submitted, that should behave differently than submitting a valid form. So these behaviors that we might refer to as loading or pending or submitted or invalid, these are called finite states. And so an event can cause one of these finite states to transition to another. So for example, if I have a valid form and I click the submit button, which is an event, now it's in the submitting state. So a finite state machine, it represents all of these things: events, finite states, and transitions, and it represents it in a concise visual diagram. And state charts, which XState also allows you to create, they actually take state machines to the next level. So you could express actions, nested states, parallel states, history, and final states, and a lot more. And so state charts, I want everyone to know that they're technically still state machines, but they also allow you to represent logic visually that scales for pretty much any level of complexity, which is a limitation of state machines. State charts pretty much solve the scaling problem.
So this is compared to probably how most people approach their state in their applications. This is a much more like formalized way of doing it. So how did you arrive at, state machines are kind of the solution to how I should build my app, rather than like a bunch of used states or something similar?
Yeah, so I didn't take any, I took a couple of computer science courses in college, but it's not something that I studied heavily. And a lot of people, they would tell me like, oh yeah, I learned about state machines at university because they forced us to learn it, etc. That wasn't the case for me. It was actually, I was a junior developer. My first, I guess you could call it my first big boy developer job. We were working at a startup where we were writing all of these complicated workflows and multi-step forms using PHP, jQuery, and like in obscene amounts of conditional logic. And on top of that, the requirements kept changing. So, we just had this really, really complicated logic, and we weren't sure what was correct, what was not. We were basically just feeding code to our QA team, and they were telling us, hey, this doesn't match the specification. And it was very difficult, especially for me as a junior developer, to understand everything that was going on and to map the requirements to the code. So I started just looking up visual ways of representing this logic, and eventually I ran into state machines and state charts. And that was the aha moment for me. Like, not only the fact that it was visual, like literally all I'm doing is following boxes and arrows, but also that almost everything that, we do in application logic can be represented in terms of these three things: events, states, and transitions.
Yeah, I think it's really interesting in that sort of the scenario you described is like something we'll all be familiar with. Is like we have a lot of imperative logic, a lot of like conditionals, and we're trying to manage state alongside the events that mutate the state, and all the logic that goes into that. So it's interesting that we have a tendency, especially if people are like developing React applications in particular, to think about like, oh, here's my like little unit of state here, and here's all the other things that impact it, and they're like very divorced from each other. But this takes more of a sort of centralized approach to like
exactly
describing the whole system. It's cool.
Right.
So, what sort of problems do you think really lend themselves well to state machines and state charts?
So I would say in general, when you're dealing with event-based code, that's a very good, first step to realizing that this app could make use of a state machine, which, like you were talking about, centralizes, these states, events, and transitions. And I mean, also there's a realization that virtually all apps have some sort of event-based code, whether we're explicitly coding these events or not. Like, even if we're putting logic directly in an event handler, like we're still handling an event. It's just where that logic lives in the component versus in some centralized place. As far as finite states go, I would say, for example, multi-step forms, or when your application has different behaviors over time, like modes. Drawing apps are a very good example of this. If you are drawing something versus if you're panning the screen, then moving your mouse is going to be doing something different than if you were like in drawing mode where it would actually draw onto the screen. But yeah, so workflow-based code as well, where you have a sequence of a sequence of steps that need to happen. And especially if those sequence of steps aren't linear. So you might have one step that might do one thing or might do another thing depending on some logic, some condition being met. Or you might even have a step that needs to go back to another step. And doing this in code, you might think like, oh, I'm going to be fancy and use a linked list, and then eventually a DAG, a directed acyclic graph. And then eventually you realize, no, I actually need a state machine that allows me to just represent all of this logic in one simple graph. But yeah, so I would say applications where it's, you have a lot of events, a lot of transitions, and a lot of states happening. And these are typically applications that are more trivial than just your basic CRUD applications, even though those could use state machines as well. All of these types of apps can make good use of state machines.
Does defining your logic in a state machine make things like testing easier?
Oh yeah, absolutely. So, and that, going back to the aha moment for me, the fact that your state machine is just states, events, and transitions, you're basically narrowing everything that you could do in your applications down to just sending events somewhere. So you could say, okay, let's say the user clicks this button and, it's fetching data, and that data has to come back, and then we have to assert that the logic that is performed afterwards is correct. The clicking of the button is an event. Receiving that data is an event. So if you wanted to unit test that, you're just sending events, and you're asserting that the final state is what is expected.
Oh, cool. What is so when? And so it sounds like there's a lot of benefits. Being able to describe your system and the interactions, and specifically the things that change state and how things transition, and also being able to isolate all of this in a very testable manner. So what are the rough spots and challenges that people run into when they're trying to convert a code base to use state charts or state machines?
I would say the biggest one is the learning curve. And I say the learning curve because, like I was talking about, there's really only three main things you need to get started. And that's, your finite states, events, and transitions. However, thinking in terms of state machines can, commonly be sort of a roadblock to a lot of developers who are more used to thinking in, I guess, different ways by manipulating Boolean variables or thinking in terms of imperative logic. So, especially when it comes to state charts, there is that terminology barrier as well. You do have to learn a lot of terms like what is a parallel state and nested states, history, final states, and what is raising an event versus sending an event, and all of these little things. And it's very easy to get overwhelmed when you're taking everything in at once. But I would recommend, just starting simple, start with states and events. I would also say like one of the rough spots people run into is just knowing how to best model state machines. And this is fair. It's more of an art than a science because really you're trying to be creative as a developer. You're trying to say like, all right, here's how I could best model my logic in an orderly way rather than it just being a free-for-all. And often we think that, just modeling our logic and, using Boolean variables and just shoving states and logic wherever we feel is most convenient might be easiest. But I would argue that in the long term, this becomes more difficult to maintain where your code reaches this state of don't touch anything. It's working, I think, and I don't know why it's working, but we're just going to leave it alone. If you remove this, then everything will break. So state machines really force you to explicitly model that in a way that's a lot more maintainable. And that explicit modeling can be more difficult than just, coding the way that you normally code. So in short, the learning curve and I guess the modeling aspect of it as well. But modeling actually does become easier over time, just like anything, art related. I like making the art analogy because as a pianist, it's like piano is not an easy instrument, but the more you practice, the better you get at it. And so same with CSS, same with modeling state machines and state charts.
Yeah, I mean, it's in some ways, it's just like writing scalable code. I found the one issue or the one like hurdle that I ran into when I was like first exploring state charts is like the tension between having a monolithic state chart where you have a big sort of complex system and you like model all the states in the complex system versus like breaking it down into smaller systems that you then use independently is a sort of interesting thing to work through.
Right. And that's where you get more into the actor model where it helps with that. But again, that's a balancing act. Like you don't want to basically turn your applications into a microservice architecture just because, you're like, oh, I can make this simpler. So, and that's the thing that I wish more developers realize too, is that a lot of coding, it's not that there's no one single right way to do it. There's not like when you reach 500 lines of code, you need to separate it into like another microservice or something like that. It's definitely more of an art than a science.
Yeah, my hurdle when approaching XState has always been like, I don't really see the usefulness when it's small, and then I'm like, okay, I don't need to learn it. But then I get to where it's like big. Like for work, I coded a tree view component, and tree view, like an accessible tree view, is an insane amount of code. Like it's one React component, but it's like 2,000 lines of code. And at that point, I'm at that place you were describing where it's like it's so big and it works, so just don't touch it. But it has all these nuances in it that are very hard to like just grok from like a high level view.
Yeah, and I've heard that so many times where at first people will tell me like, hey, my app is so simple that I really don't need a state machine. I'm like, okay, that's fine. And then later they will say, hey, I actually really wish I used a state machine, but right now it's at the point where it feels like it's too late. So, and again, I think that's part of the fear that people think, oh, there's so many terms to learn and it's going to be a huge learning curve. But there's steps that we could do where, we could just start modeling in terms of events. And that doesn't require you to split everything out into states and transitions. It's just send an event instead of directly manipulating state. And that actually makes it a lot easier to eventually migrate to state machines when you feel the need for them in your applications.
I feel like another big challenge, or that can be a challenge when you're approaching sort of like implementing state machines or state charts in your application, is just like how exactly they're expressed. Depending on the complexity of it, there's a bunch of different ways to express these things, and you have this, what is almost this graph that's like multi-directional with nodes like pointing at nodes, and it's like it's a sort of a complex representation, and describing that in code can be really hard. So the first time I ever played with xstate, which this isn't unique to xstate, but it is like I had a bunch of like nested objects, and it became hard to like to look at the code that was happening there and be like, what's going on? I could run it through a visualizer and generate the chart, and it's like, this makes sense. And then but like looking at nested objects is like, a hard sort of thing to grok sometimes. But again, not unique to xstate in that. And also of xstate in particular, and then a lot of like this space has been making some tremendous strides in like better tooling and like different ways of approaching this. And I'm super excited about that.
Yeah, exactly. And trust me, I'm not a big fan of the object syntax either, like the big nested object syntax. But as far as being able to express nested directed graphs in code, honestly, like what else are you going to do? That's one of the, best ways to do it, even though it doesn't, seem the most visually appealing. And you actually gave a clue into like sort of more the end game, where it's that visual representation. Like for the longest time, I had the xstate visualizer in various iterations, and now we're going the other way with the visual editor, which allows you to just create these visually, which are a lot nicer to look at than huge nested JSON objects. And also having it as a JSON object does allow us to do things like bidirectional editing and static analysis, and also visualization as well, because you could copy and paste that structure, and actually you could even convert it to different formats in the future, or even easily consume that in different languages, because it is pretty much JSON at that point.
So we've been talking, I feel like, mostly in the context of front ends, but do state machines like scale across the stack? Is the best place for them in front ends, or can I use them anywhere?
Oh, I would say front end and back end. When I first created xstate, I was mainly a front end developer, so of course most of my interest was using them in the front end, especially for complex components, multi-step forms, routing logic, and things like that. However, the more I've seen xstate getting used, throughout the web world, I've seen it used in so many different places, including the back end. People are using it for workflows, for chatbots. I've even seen uses for home automation, Web3 projects, things like that. And more recently, I've realized that, honestly, a lot of the logic that we do in the front end is basically the same logic that has been written thousands and thousands of times before by many other developers. Like really nothing, it's like nothing new under the sun. We're all basically writing the same thing. However, when you get to backend logic, that's where the story changes a lot, where every company's, collection of workflows that they have in the backend, whether they're explicit or not, they're all different. And they're different for good reasons, because these companies have their own specific business logic, their own specific needs, and they don't necessarily want to share these workflows out in the public for other people to copy, because it is essentially what makes their business unique. And that's when I realized that workflows in the backend are one of the biggest places where like state machines and state charts are extremely useful, because state machines and state charts allow you to express workflows in even greater complexity than most workflow engines out there today.
Yeah, that's pretty cool. And I think something we've talked a lot about on the podcast, and something I'm very interested in, is the notion of visual programming, or just visualizing programs, and part of that is, how do you represent, logical cohesion? How do you talk about the states that a system can be in? And like, I mean, I think it goes without saying that like state charts are the sort of de facto formalized way of doing that. And from an industry perspective, I don't know that we have something that has a spec in a similar way to really describe the shape of the things. Like, I mean, like state charts, because I mean, XState itself is actually based on a standard, right?
It is. So XState is based on the W3 State Chart XML, or SCXML specification. It was created in about 2015, and I think its main use was in voice systems like IVR systems, where it's like press 1 to get this next menu of options. But it's been used in many other things. And the purpose of SCXML is, as the name implies, to tie itself closely to state charts, which were created by David Harrell in 1989, and also formalized in the UML spec, but they're not exactly the same. So yeah, and I think like the notion of using a specification for defining these state charts is really useful, and that's been one of the main influences on XState as an API.
Yeah, I find it amusing in your docs how you're like, oh, this is based on a 30-plus-year-old specification. It's not your like shiny new state machine thing.
Exactly. I love to say how like this is old, like in an era where we're just creating new tools and frameworks and things where it's like, hey, this is brand new. I have no idea how much it'll scale or if it's battle tested or not. We're just going to experiment with it because it seems buzzy and fresh and new. I really like to lean on the fact that the technology we're using is extremely old. It's based on state charts from 1989 and even state machines from like way earlier. State machines predates computers. So, yeah, and I think that that's actually been refreshing for a lot of people because I guess that shiny new object syndrome really gets to you sometimes. So having something that has indeed been battle tested and used in many different industries like automotive, embedded electronics, aeronautics, game development. That's huge for state machines. There's definitely evidence that state machines and state charts are very useful for many different use cases, and so that's why I'm honestly most excited to just bring it to web dev.
Yeah, it's an interesting example of old is new. Like another one I can think of is design systems. Like design systems have been around for forever, but we're just now starting to use them in code. And it's like, oh, wait, that's a real good idea.
Mm-hmm. Exactly.
So when you first started working on XState, or sort of before that point, given that the specs and the ideas are not new, was there stuff that existed in the ecosystem that like did state charts and state machines, and sort of what was the sort of impetus for creating XState itself?
Yeah, there were a few things. I mean, the main impetus was basically me scratching an itch and wanting to use this in my front-end projects. There were a few existing libraries. Some of them were actually pretty popular at the time, but they focused just on the state machine aspect. So they didn't go deeper into state charts. And I remember like after reading Harrell's paper and reading through the SCXML spec, I really wanted something that captured all of the features, both in his original paper and SCXML, and also something that was easy to use in my front-end projects. And so I couldn't really find anything like that. So that's why I actually toyed around with Peg.js, which was a way for you to make your own languages. And so I created like a very simple DSL for state machines. I released, basically the first version of XState. And for the first year, got all of 7 stars. It did not make any sort of a splash ever. And then eventually I presented it at a conference where it was React Rally, I think in 2017. And I think in that talk, it gave that aha moment that I felt to a lot more people where it's like, hey, this might be a better way to represent my logic. And also I could visualize it too.
It's funny that you started out as a DSL because other people have now created DSLs for XState, like Lucy from Matthew CP.
Yeah. Lucy is a really interesting experiment. He also created robots, and robot is another state machine library. And I honestly love the fact that, there are these, smaller state machine libraries that are influenced by XState, but they wanted to change around the API. I just really appreciate that state machines are gaining more prominence slowly but surely, in the web dev space. But yeah, Lucy is definitely an interesting DSL. There's another one called StateML. That's another interesting DSL to look at. I think it's still under active developments, but right now we know that there is a friction point when you do introduce like a custom DSL to the web community. They don't want another compile step or another build tool. They just want to copy and paste something directly into their JavaScript apps and use it directly.
Yeah, I think that's incredibly valid. I think the interesting thing for DSL is like when you're expanding outside of the JavaScript ecosystem and you're starting to talk about, hey, here, let's have a common language that, back end or front end or like whoever, wherever. That's where DSLs and, importantly, which I want to get into, visualizations are incredibly important. So maybe let's switch gears and start talking about Stately. So you're the founder of Stately, which is sort of a company behind XState. You want to talk a little bit about like what the goal of forming a company around this is, and sort of what your vision for it is?
Yeah, sure. So XState was mainly a mornings, nights, and weekends project, but eventually the community grew, large enough that I realized that this is too important to just be a side project. So that's why I decided to just go through all of the steps of, forming a company out of Stately. And I realized that, there's a lot of bigger goals that I want to accomplish with Stately. And so a summary of Stately is that it's a visual software platform for application logic and workflows. So in a very, very short elevator pitch, you could basically think of it like Figma for logic, both in terms of visually designing your logic, being able to collaborate with teams on your logic, and also just providing you tools for making your logic correct. So that's my biggest goal with Stately.
Interesting. So like what does it help you to make it correct?
So have you ever, or actually let me pose a question in a different way. What tools do you use when you're, just talking through architecture or flows? Like what kind of diagramming tools do you use?
Like Excalidraw or TLDraw
Right.
or something like that. Right? Yeah.
Exactly. Yeah, there are so many great tools in that space. You named Excalidraw. I love TLDraw as well. Miro, even Figma, FigJam, Whimsical is a great one too. Just all of these tools that allow you to easily just draw out flow charts or just these architectural diagrams. But here's the problem. Once you draw these things out, they're merely an artifact. They're just like a JPEG or PNG or, SVG, and you could copy and paste them into documentation, but there is no guarantee that that diagram actually represents what the code is actually doing. And so when you change the code, the diagram could go out of date. If you change the diagram, again, the code, like it might not match with the diagram. So you can think of Stately as a diagramming tool or a set of tools for creating these executable diagrams that actually stay in sync with your code. And so that way, the whole correctness point is sort of twofold. First of all, it allows you to express your logic using state machines and state charts, which allow you to, to statically analyze your entire logic. Because if you know all of the states, events, and transitions, like we talked about, of your application, then you could, it becomes possible to just to list out all of the possible paths and ways that a user can use the app. And so there's no more guesswork. You know all of the features that can be done. You know all of the events that could be sent. And using the actor model, you even know all of the services that your app can connect to. And it is a visually complete diagram, which means like there's not going to be any hidden or unexpected logic. It's all laid out there in front of you. And so you could analyze that, simulate that, etc. And so the second part to that is actually at a higher level, where you could take it to the rest of your team who are non-technical, such as designers, project managers, and other stakeholders. And believe it or not, these are the people who are actually most helpful in taking a look at these flowcharts that you created and validating that behavior, saying like, hey, this is not supposed to happen. This arrow should actually go there. Why is this feature here, etc. Like they could act, or they could even ask questions, clarifying questions to make the models even better. So I guess it's two ways of just ensuring correctness in your application logic.
Yeah, really, it takes away the hurdle of, oh, I don't want to learn the XState API because it's like it just generates XState, right? For
now, yeah.
Oh, for now. Do you plan on it generating other things?
Yeah. So, when we're talking about application logic, obviously XState is not, the only way that you could represent, your state management logic. And especially when you're dealing with other languages, XState might not be available for that language. And so you could think of Stately and the Stately tools that we're building as eventually becoming this directed graph builder. So anything that you could represent in a directed graph, which, surprise, there's a lot of things that could be represented as directed graphs, you should be able to express in and to create in the Stately Studio, we call it. So I'm actually recalling one of my favorite tweets I read was someone who said, hey, my QA team absolutely loves, or I think it was a QA team, but loves using the Stately editor to basically draw out flows and model application logic and be able to have a very clear visual picture of, of what the application logic is. And someone in the comments, just tweeted back like, oh, awesome. Do you use XState in your app? And he said no. And that actually got me really excited because, it shows the usefulness of these tools beyond XState. So even for creating CI/CD workflows or, just workflows in general, because this is more poised to be a directed graph editor, XState becomes just one of many possible outputs of that.
Cool, that's cool. But is the end goal is still code generation ultimately to make this like a real integrated graph, or is it that just like a side goal?
The ideal goal is actually bidirectional code generation, which, we have accomplished to an extent. So, you could edit your code and that updates the diagram. You could edit the diagram directly and that updates the code. So yes.
That's awesome.
How does that exactly work? Like when I open Stately, what do I pull in? Or like the opposite? How does that bidirectional part has me a little confused?
Yeah, so this is actually something that you could play around with right now. There's a VS Code extension for Stately and XState. And so the way it works, I can't tell you exactly how it works because there's people smarter than me working on it. But the way it works is that if you have, state machines, and right now, of course, this is only working for XState, but if you have an XState state machine in your application, you're going to notice an open in editor little leaflet button thing on top of there. So you click that, the editor opens to the right. And so what's happening is just a series of AST transformations and just internal mapping that allow you to take that JavaScript or TypeScript code, map it to a digraph representation that the editor can understand. And while you're editing the digraph, it's sending commands back to VS Code saying, hey, this is the relevant part of the code that needs to change to stay in sync with the diagram that we created.
So is there operations where you go into the editor and you update the graph itself without having VS Code open, and then it like does a commit to your repo or something? Or is it like is it tied to VS Code as a...
That's coming in the future. Yeah, we're working on a GitHub integration, so within the next few months, hopefully we'll have something out for that. But that's essentially what we want to do. And so that will enable people to say, hey, this logic is wrong, or we have to fix it, or maybe add a new feature, which could just, be adding states, events, and or transitions. And so you should be able to do that visually, press save, have it sync to your GitHub repo, and have it be just as if a developer committed code.
That's really awesome. So often when we're talking about companies in relation to open source, and especially JavaScript libraries, is like talking about monetization and how you make a company sustainable is an interesting question. It seems like your path forward with Stately is probably a lot more clear when you have like a collaboration element, right? Because there's like things like Figma and other tools in this like collaborative space have really set forth a clear model. But when you're thinking about making Stately a sustainable business, is like what does your mind go to, and how do you think about that?
Just like you said, our mind goes exactly towards collaboration. And that's because one of our biggest goals and visions is to make application logic collaborative, because frankly, right now it's not. It's a silo between design, project management, and developers. And there's very lossy communication between each of those three silos. So basically, we want to enable collaboration for the most important part of your business, which is that business logic. And that's where we see there being like that, monetization model, because we want to build collaborative tooling and advanced features that teams would actually pay for and that teams would find value from. So this includes things like, being able to define teams in the Stately Studio, having advanced visibility settings, versioning your machines, advanced analytics, the GitHub integration that we talked about, more export options and embedding options, and the list goes on and on. We want all of our tools to be useful for individual developers, especially if you're working in open source. So we do want to have that free and open model for these individual developers, but we want, teams to pay for our tools.
So one thing you said a few minutes ago kind of piqued my interest, that like on the front end, at least, we write these state machines that are like basically the same state machines over and over again. Since you kind of have like a cloud platform going, is there like the opportunity to like let people publish their state machines and then like fork them kind of? Because like going back to my tree view example, like there's a spec for the tree view, like that should have kind of like a standard state machine that I can just like implement my thing on top of. Do you guys have any plans for that?
Yes, we do. And it's actually something that we're actively working on, and we pretty much have a version of that already. So if you go to stately.ai/registry, then you're going to see an entire collection of machines that you could just take a look at, fork, export as JSON, which you could include directly in a create machine call to xstate and use that logic directly. But yeah, that is one of our big visions, is the ability to have these common machines and have these represent just common bits of application logic, from something as simple as, components such as a toggle component to something more advanced like authentication and authorization. And so, we want people to be able to fork these machines, tweak them to, how they want it, and then use it in their apps however they'd like. One of the biggest problems I see with the way that we currently do things today is that if we want like some specific, bit of logic that we know exists because, many apps have this same logic, but we're like, we don't have the time to write it ourselves, or it's too complicated for us to write ourselves, you really only have a few options. You have to look for a package that's for your specific framework, and you have to make sure that that package is well supported, well documented, and has all of the knobs that you could turn so that you get your exact logic. And if you need anything changed, you are beholden to whoever is the maintainer of that project. You could make a PR, you could file an issue, and you could hope for the best. And eventually, you'll have your use case satisfied by their changes. And I don't think that this is the best way to do things. I really think that that application logic should be composable like Lego bricks. And just like Lego bricks, if you need to tweak any of the logic, you should be able to do so just by breaking things apart, putting things together. And of course, with the analytical tools that I talked about, ensuring that the logic is still correct, either by simulating, generating tests, even generating documentation for these things. So yeah, that's one of our very big ideas, is the ability to share and remix this logic.
That's super cool that it even goes to like the extent of like testing and documentation too. Like that's an awesome goal.
Thanks.
Yeah, that'll be great. I'm excited about it. I mean, this is one area that, you know, every programmer ever will go through this hurdle of like having to build large conditional like flows that like are reacting to events and like putting your system in different states. And it's like, this is just sort of the nature of the business. So, you know, it's nice to see direct tooling built around this.
These are tools that we wish existed, like us and the entire team, that we wish existed when we were first developers, you know, for the last 10 years or so. And that's why we're super excited to build them.
Yeah, an interesting example that comes to mind is TL Draw. Like, you have Steve Ruiz out there, like literally going through every single design tool ever, going like, how does this line behave when I do X, Y, and Z? And he's basically just making a big state machine for a canvas-based editor. And like that's the very big valuable part of TL Draw. Like here at Descript, we wanted to use TL Draw for like our canvas renderer, but like our canvas is actually rendering a video, so it has like the concept of time too. So like we really can't use like TL Draw itself. We can only take inspiration from it. But if TL Draw's logic was in a state machine that we could just like fork and remix, that would be like chef's kiss, like so easy.
Mm-hmm. And yeah, like you said, it is basically a series of state machines. I think Steve Ruiz is, you know, using his own libraries to create those state machines. But yeah, it is really interesting. And TL Draw, that's like one of the most, I guess, poster child examples of an application that would make really good use of state machines and this event-driven logic that can get complex really easily.
And it does use state machines. Yeah. He's got his own special sauce under the hood.
He does.
Yeah, the problem with developers, we like to make our own shiny thing.
Yeah.
Also a non-trivial thing. I'm sure David knows all about it. Digging into XState is even though the specification is well defined, there's a lot of aspects to it. We were talking about the learning curve earlier. Implementing something correctly is non-trivial.
Right. That's right.
Well, that's it for this week's free portion of the episode. If you want to listen to the full conversation with David, head over to our Patreon and become a member. For just $5 a month, you can help support the show and help us get to our goal of delivering content weekly. Thanks for listening.